Show you a quick demo of how our user interface for RIS will work. Since it's a web-based application, you should be able to access this application on any web-based browser. However, for this demo, I will be showing you a demo on an Android device. As you can see here, you are presented with a login portal that offers two levels of authorization, Level 1 and Level 2. These authorization levels have been described in detail in the previous presentation. At first, I will log in as a Level 1 user. You can see that as soon as you log in, a Level 1 user is presented with report numbers. These are cases of H1N1, the city that they were detected in, the reported time, and the date. You can scroll through the lists as well as sort based on each label. In addition, you can see their maps. Currently, our data is based on provincial data. However, once data is completely received from OLIS, we will be able to receive data at the city level. You can change the gradients of the heat map, you can change the radius for easy viewing, the opacity, and also toggle the heat map so that you can actually get into the actual information. In addition, we also have 10 prediction. This is offered for every province. For Alberta, you can see that the real data is in green, and the predicted data over the next 3 days is in this orange color. Similarly, the trend is presented for BC, Manitoba, and New Brunswick. Now, I will take you through the Level 2 authorization system. Oh, it seems I've incorrectly entered the password. In the Level 2 user portal, you can see that case details are a lot more detailed. You see the name of the case, the full address, their phone number, the time the case was reported, and the date. Similarly, as case Level 1 details, you are able to scroll through the list, and eventually you will be able to sort based on these labels. The mapping system for Level 2 users is a bit different. Cases will be mapped based on their individual addresses. For example, if someone wanted to conduct an interview with someone in Kitchener, a case in Kitchener could be located down to the address, right next to Resurrection Catholic Secondary School. The last component, once again, which is the trend prediction model, is similar that it was for Level 1 users. And this is a brief overview of our user interface.
In this part, you will see the performance of our model. Our model is coded in R language programming. The code consists of different components. The first part, retrieve data based on the user input. The second part, generate daily data based on weekly data by using linear interpolation method. The next part will use the ARIMA model to predict trends for future. We will use the error and correlation to evaluate our model. Now let's run the program. By running the program will ask for a province name. I'm going to enter Ontario as an example. You can see the performance of the model here. The red line is the predicted data and the green line is the real data. As you can see, our model follows the actual data pattern very well. Our model is a real-time trained model, which means when a new data comes, our model will be trained again. By pressing enter, I'm going to show you the error of our model. This figure shows the error for our model. You can see that by receiving more data, the error will be less, and at the end, the error will be near zero. I'm going to press Enter to view the correlation. The correlation measure is 0.97, which means our model is following the actual trend very well. Now you can see the overall performance of our model. Here, the orange line is the predicted data and the green line is the real data. As you can see, although there are some points that our model didn't work well, the model follows the actual trend very well.
For the GIS component in our application, we make use of the Google Fusion Table API and Google Heat Map layer to map the required data. The Google Fusion Table API stores data in the form of a spreadsheet. The first column here shows the locations. For the demonstration, we are using provinces of Canada as our location column, but for the fully developed application, we will be mapping the data on a heat map for various cities in Ontario, as the data provided by the Ontario Lab Information System is city-based. It can be mapped in the very same manner. The rest of the columns are the number of cases detected in each of the province for 168 continuous days. The heat map will display the data from the spreadsheet. For the first day, number of cases is the highest in Quebec, and it can be seen on the heat map that there is a red spot on top of Quebec, which indicates that the number of cases is highest in Quebec. Moving forward, on day 4, we can see that the number of cases is also getting higher in British Columbia and Alberta. For day 9, it can be seen that the cases are getting higher again in British Columbia and Alberta while lowering in this region. This mapping could help in indicating a spread of influenza in this region.